Hi, welcome to Chapter 7 on cut scores with the EMS Testing Online Item Writing Workshop. In this chapter, we're going to talk about defining and describing what a cut score is, how you go about determining a cut score, and differentiate between published cut scores, calculated cut scores, and raw scores. So what is a cut score? A cut score by item is how good, sophisticated, are the wrong answers. It's also what one might argue is a probability based on how many good wrong answers there are. If it's over a test, it's just the average of the cut score of each item. And the passing score, the assigned passing score, then is based on that probability. So let's give some examples or get a little bit further into this, and I think all that will make sense. So first off, to determining what the cut score is, we use the Nadelsky method. Now, Nadelsky was a statistician and basically looked at what is the likelihood that you know what you're talking about versus you're just guessing on a multiple choice item. So if there are 4 items on a multiple choice, how many good wrong answers can there be? Well, there could be none. There's just the right answer and 3 wrong answers that aren't all that good. 1, 2, or 3. If there are no good wrong answers, no good distractors, so there's the right answer, the other 3 are plausible but not good, it gets assigned a cut score of 0.9. So the item would be assigned a 0.9 cut score. If there's 1 good distractor, so there's the right answer but this other really good one and I can't decide between the 2, then the assigned cut score of that item would be 0.6. If there's the right answer and 2 really good distractors, wow, it's one of these 3, then the item would be assigned a cut score of 0.45, and if all the 4 answers are pretty much the same, you would need a 0.36. If you take a look at this last one, all 4 are pretty good. If you were just guessing, you'd think you'd get a quarter of them correct, 0.25. So notice the requirement's a little bit higher, and that's really what the statistic or probability game is. Just that you're better than just guessing. A 0.25 would be an expected guess. 0.36, you're better than just guessing. Similar way, if you look at there's the right answer and 1 really good wrong answer, it's cut at a 0.6. Well, if it was just between the 2, you'd think a 0.5, 50-50. But just a 0.6 demonstrates or above would mean that you know if you got 60%, you probably know what you're talking about. So again, all you have to know is not how these numbers are developed, it's just a chart. No good wrong answers, assigned a 0.9. 1 good wrong answer, assigned a 0.6. 2, a 0.45. And if all 3 are good wrong answers, then it's assigned a 0.36. So, kind of a method to do this. We're going to suggest that in this example here of these 5 questions, 24 people total took the test below. And what we define as a good wrong answer is that at least 10% of the people taking the test selected that answer. So item number 1, A is the correct answer. 10 people, well over 10% of the population, which would be 2.4 or 3, 10 people selected item B. Only 1 selected D and only 1 selected C. So that would not be determined as a good wrong answer because not enough people picked it. You'd need 3 or more. So it has 1 good wrong answer. That good wrong answer is the letter B, so it would be cut at a 0.6. On number 2, C is the correct answer. 1, less than 10% picked it for A. 2 for B, again less than 10%. And 2 for D, again less than 10%. So though we have 2, 4, 5 people who missed this question out of the 24, their distribution is such that it made none of the other choices good wrong answers. So there are no good wrong answers, so this item would be cut at a 0.9. Number 3, there are the correct answer, B. 4 picked A, 4 picked C, and 4 picked D. So of the 24 people that chose this, half of them didn't even select the correct answer, but they were distributed such that evenly distributed for A, C, and D, all greater than 10% of the population. 3 really good wrong answers. That item is cut at a 0.36. Number 4, you have 2 choices that have greater than 10%, A and B. So it has 2 good wrong answers, a 0.45. Take a moment, look at number 5. How many good wrong answers are there? And as you look at that, you see that C is the correct answer. Only one picked D, nobody picked B, but 9 people selected A. It would have 1 good wrong answer, therefore its cut score would be 0.6. So that's what you should have for that one. So, gives you some questions, and how would you determine how many good wrong answers are? So we're going to ask, how many bones are there in the body? Is it 55, 100, 130, or 206? As we look at this, we say, correct answer is 206. Are any of the other 3 even close? Nope. So how many good wrong answers are there? Probably none. Now we administer this test and we find that, oh my God, we gave it to 10,000 people and 5,000 of the 10,000 thought B, 100, was the correct answer. Wow, well, I guess there was one good distractor in there. I'm really doubtful we would find that evidence. So D is probably the right answer, and there are no good wrong answers. That would be cut at a 0.9. Whereas in the next example to the right there, how many bones in the body? Same question. 204, 205, 206, 207. Wow, those are all close. Especially if you think, okay, is that coccyx? Is that counted as 1 because it's fused? Or 3, 4, or 5 because you usually see a reference of 1 to 3 or 3 to 5 or what? How many? Which? So if you start thinking into this question, that actually becomes a very difficult question. When the first choice, it's very easy, but the second choice, even though it's the same question, it became difficult because of the quality of the distractors. How good are the wrong answers? How attractive are those? Cut score versus raw score. Raw score is just, there were 100 questions, you got 97 of them right, you got a 97%. There were 100 questions, you got 12 of them right, you got a 12%. That's what raw score is, just how many questions were there, how many did you get right, what's your percentage. Cut score, on the other hand, is instead what you'll identify based on the quality of the answers. So you have what are called published cut scores, calculated cut scores, and estimated cut scores. Your published cut scores are what you might have in your syllabus. How many, what do I need to pass your class? Well, you need to get an 80%. Student might say, is that an 80% raw score or is that an 80% cut score? You would look at that student strangely saying, are you a teacher? So most people don't understand it. So published score, it's what you tell them they have to get in order to pass. Then we have calculated cut scores. Calculated cut scores would be based more on the results of the chart we showed you at the beginning, where how many people picked A, B, C, or D. What is the distribution? And then assign the cut score based on the Nadelsky method to that. Estimated cut score is kind of what we did in the last example there. We estimated the very first one didn't have any good wrong answers, and we estimated in the second one that all 3 were good wrong answers. So those are kind of what raw score and cut scores and how they all relate. So what we'll typically do is do a conversion in the background for folks, or provide them with a spreadsheet to how to convert their calculated cut score and their raw score and associate it with what they got based on a published cut score or passing score. Another word to think of, cut, is passing, like cut from the team. What do I need to get to not be cut from the team? That's the cut score. So hopefully that helps and doesn't muddy the water too much. So cut score is basically what percentage do I need to get in order to pass this test. So if a test is cut at a 60, I would need a 60 or above to pass the test. I need a raw score of 60 or above to pass the test. If a test is cut at a 38, I would need to get a 38% or above, etc., to pass the test. How do we determine that? We determine the cut score of each item, average them all out, and that yields the cut score of the test. And then we arrange for those two to get together. So hopefully that helps with cut scores. Your purpose, basically, as you write an item, is you look at it, how many good wrong answers are there? If none, 0.9. 1.6, 2.45, and if all three are good wrong answers, you think students will equally pick those, or at least 10%, then you would give that a 0.36. That takes care of this module. Next, we will go on to our last module, which is dealing with reading levels. Thank you for your time, and again, if you have any suggestions, we would love to hear them.